Hey, you eighth graders, how I miss you guys so much. For Tuesday today, let's go ahead and grab out of your books lesson 8-3. Okie doke. Pages 233 to 237. We're just going to hit some highlights of it and then go from there. Let me see if I raise this just a little, because sometimes when I write on the sides, it doesn't show. So we're going to just take some short notes, and then let me show you what I'd like for you to do for me in your for your homework today, for your math work. I'm super proud of the work I saw for those that submitted your Khan Academy 7 problems. You did a great job showing me on your notebook paper. Be sure to put your stars or your X if you missed it. Tell how many you got right out of 7 at the bottom. Don't forget your heading. And if you did miss any, find a new box and redo those so your grade can come back up. So I was real proud of that. So that's when the Pythagorean theorem, when a right triangle is given and you're missing a side. So y'all did a super job on that. And those that didn't get it finished, we'll go ahead and get that finished first and then move on with this one. 8-2, lesson 8-2 was the lesson where it just gave 3 values. We know that we take the 2 smaller values, like if we had, 3, 4, and 5, they'll say, well, does that make a right triangle? Well, you'd say, oh, well, this one's A and this one's B. The 2 smaller ones are A and B, and this one would be C. So that's all lesson 2 was, taking 3 values, plugging it into the Pythagorean theorem to see if it makes a right triangle and if it's true or if it is not true. We did that practice. I do remember prior to, during our star and benchmark preparation. So yay, no star. But today I want us to relook at the distance between 2 points. Okay, it might be given on a coordinate grid, on a coordinate plane. It may be shown between these 2 points here. So you could use your dotted lines and still plug into a squared plus b squared equals c squared. As y'all recall, so we can count, we'd say, oh, that's 1, 2, 3, 4 for A at 4 squared plus, and label it, and 1, 2. So 2 squared equals c squared. So 4 squared, 16, plus 2 squared, which is 4, which equals c squared. So 20 equals c squared. So to find just c, we would take the square root. To get rid of that square, you mark out your square and take square root of 20. And they showed down here it was between 4 and 5, so they just put approximately 4.5. Feel free, I hope that you do have a calculator. I'd like for you to go ahead and use your calculators and do square root of 20, whether you're just using Siri or a calculator, whatever it might be. But show your whole formula and then feel free to use a calculator to find your square roots. So here, that's perfect. So let's take a look at your turn real quick and label. We want to know the distance between this point and this point. So what they might not even have that shown, class. It's just they may just have that shown, the 1 point with 1 line, and they ask, what is the distance between these 2 points? You can see it as a diagonal, so you go ahead and draw the right triangle yourself with your dotted lines. And we know this side is 1, 2, 3, 4. This side is 1, 2, 3, 4, 5. Excellent. So then we would use a squared plus b squared equals c squared. Again, 4 squared plus 5 squared equals c squared. 16 plus 25 equals what? 41. So c squared equals 41. So the square root of 41 would give us C. So to mark off, we just want the value of C by itself. We mark off squared and take square root of 41. All right, and I didn't bring my calculator right here, so somebody could figure that real quick. And I wish I could pause, but anyway, it's not important. Let's just go on with it. We would do square root of 41, which what they're saying, take the two numbers it's between, and let's just check that out. Let's just do that for some fun. If I didn't have a calculator at all. Let's see. What? Let's see. 5 squared is 25. 6 squared is 36. And 7 squared is 49. So 36 and 49. 41 is 5 away from 36. And okay, so it's a little less. Approximately, C is approximately 6.3. There you go, friends. Do you remember how we did that once before? All right, let's go to the next page and check it out. Here's the big deal of today's lesson is finding the distance between 2 points, any 2 points. Finding the distance between any 2 points given in ordered pairs, class. When you're given 2 ordered pairs, we know this would be x1, y1. This would be x2 comma, y2. And we can remember very well what the distance formula is. All right, so let's remember it's x2 minus x1 in the first parentheses, x2 minus x1 squared. Okay, so we parentheses and square it, plus, which is like a squared. And then b squared would be y2 minus y1, and square it. So add those up and then take the square root of it. So we need to get very good at remembering what the square root of x2 minus x1 squared plus y2 minus y1 squared. And then take the whole square root of it. That's very, very good. So that's what we'll be doing in this lesson. They say use Pythagorean theorem here to derive at the distance formula. We're going to use, oh, what? Low power mode, my phone just said. So hopefully we'll make it through this video. I hope that video didn't go off. But anyway, let's just see. It says use Pythagorean theorem to find D, distance, the length of line PQ. So let's all go put P and Q, a point. So let's give the ordered pair for P, class. So P, as we see, is over 1, up 1, 1, 1. Q, that's P. And Q, let's go count. 1, 2, 3, 4, 5, 6, 7. Over 7 and up. 1, 2, 3, 4, 5, 6, 7, 8. 8. All right. So we can see this is x1, y1, x2, y2. So let's show that we are going to take 8 minus 1 and 7 minus 1. So we have, go ahead and let's keep going. So let's rewrite it again. What is 8 minus 1? 7 and square it. Plus 7 minus 1 is 6 and square it. All right, so let's go with it. Keep going. 49 plus 36. And take the square root of it. Here we go again. Now let's add. 6 plus 9, 15. Let's carry 1. 3 and 4 is 7. Plus 1 is 8. So the distance between the 2 points would be D equals the square root of 85. Shall we go with it? Let's go with it. I'm mad at myself because I didn't have my calculator. I meant to right over here. But we got, we know 9 squared is 81. So it's just a shade over 9, isn't it, class? Because we know 10 is way up at 100. So it's just barely over 9. So D is approximately 9 point. I'm going to just say 1 and box it. So we get the feel of using the distance formula in this lesson. And that's what I want you to get the most practice at, since you've already done a lot of using just the formula. All right, there's a whole nother one. As you can see, they want to know the distance between the house and the beach, let's say. Okay, you see the house and the beach. We've got 10, 20. We know we always use from the left dot and as the first ordered pair, and the one that is to the right is your second ordered pair. 280 minus 164. Sorry about that. So again, you do your x's first. 280 minus 10. So we're going to do square root of 270 squared plus 164 minus 20. That would be 164 minus 20 is 144 squared. Now there we need some big time calculator. They've done it for us right there. Very, very good. So the square root of 270 is 72,144 squared. 20,000, add them up, you get 93,636. And you take square root of 93,636. And the answer is neatly 306. Okay, so the distance from Francesca's house to the beach is 306. What are we talking about, meters here? Or I hope just meters, or they never said. They never really said, did they, class? Hopefully she doesn't live 306 miles from the beach. She sure couldn't walk, could she, guys? I sure miss y'all. Let's keep rolling. Okay, the next page, of course, shows guided practice. Here, what would we use? We would have to use distance formula. Between her house and Camp Sunshine, you would use the distance formula. Everybody try to write it yourself. Square root, D equals, what would I put inside? Okay, what would I put inside? X2 minus X1 squared plus Y2 minus Y1 squared, and then take the whole square root of it. Yes, yes? Good. So we know what to do here, but look at this one. What would we do on this one? To find the distance between here and here, we would use our dotted lines. 1, 2, 3, and 1, 2, what? 1, 2, 3, 4, 5 here. We would use a squared plus b squared equals c squared. All right, friends, when they give it to you as simple as that, use your a squared, b squared, c squared. When they give you 2 ordered pairs, use distance formula. Good, good? Excellent. All right, and here, to find the distance between the 2 planes, here's a plane, here's a plane. American Airline, United Airline, what's the distance between them? So therefore, you would have to use distance formula using these 2 ordered pairs. Which one goes first? This one. This one goes first because it's on the left. The one on the right are your x2, y2 values. x1, y1. x2, y2, because it's on the left and then on the right, just like you read a book. No problemos. Excellent. So now that comes to end 8.3, independent practice. And you can do this. You can do this. Just count. Use your dotted lines on this one. my friends, use your dotted lines like I showed you in your notes to find the distance of the longest side. We know the longest side is opposite the right angle, which is C. This is A, this is B, this is C. So, of course, you will use A squared plus B squared equals C squared. And I want to see the work underneath your formula. Very nice. Here, we're given two ordered pairs. So, you definitely need to use your distance formula and either show your work. I would grab a piece of notebook paper and take a shot of this, or put it right beside it and show it was number 6. And if you can take your photo of the whole thing with your work shown over here, that'd be grand. You do what you can, all right? But then I want to know to the nearest mile. It says round your answer to the nearest tenth, excuse me. If each unit represents 1 mile, how many miles apart? So you be sure to get your answer and show me in miles. Okie dokie. Look here. You got to go graph. You go graph every one of these over here, my friends. And you're going to plot these points on the plane and draw the rectangle. Then connect points E and to T to form the diagonal line ET. Then use your Pythagorean theorem to find the exact length of ET. All right, so you choose which system you're going to use. Are you going to use this, or are you going to use the distance formula, my friends? Actually, then it asks, how can you use the distance formula? So go ahead and do dotted lines on A. I want you to do dotted lines on A. And then I want you to use the distance formula on B. How's that sound? Yeah. And here we go. Which ships are farthest apart? Just don't do that one. If you can get these done for me, friends, I'd be really proud of you. Take a picture, show your work, use your calculators, do a great job. Put your regular heading up at the top. All right, guys and girls. I need you to know I love you so much. I miss you so much. And big hugs to all of you. Everybody take you give me a little selfie picture in the comments so I can try to save that picture and make myself a little collage so I can have a collage of all my awesome 8th graders. And if you see somebody else not getting things posted, I don't know if you can tell or not. I will. Talk to your friends. Make sure everybody's getting their math done. Do a good job. Love you. Have a good day. And we'll check in with you tomorrow. Bye-bye.